All right, just a few things that I wanted to mention.
No class on Friday.
Well, there's no class on Friday.
Also, right now.
What time are we leaving on Thursday? Do we know yet?
Probably sometime around 1.
Okay.
Hello.
Literally everything's next weekend and I can't go in.
Sorry. It was your idea for what you
I
said.
know.
So are we doing that networking thing Thursday night or no?
I think apparently it's just for the speakers. So
Oh.
Ash wasn't going to dinner, and apparently
We're not doing anything.
Apparently we're going to go to dinner.
That's okay.
You get to hang with Dr. Joe and Ben, yeah.
I heard RJ's going too.
Yeah. But he won't be there until after we get there.
Yeah, because he said he had some things.
Yeah. Yep. It's true.
Can you go through test problems?
I will talk about some of them. Not going to do all of them. I'm going to mention a few things. Let's see. There were 3 things. Let's see if I remember all 3 things that I wanted to talk about. One of the first things I want to talk about was number 3, just briefly, because there's a couple. I think there's a couple of ways that you can think about it. I do want to say, in general, when you're doing these problems, make sure you keep all of the digits in your calculator as you go through. There were some rounding error issues that did pop up. Not that most of the problems are written so that if you do have a little bit of rounding issues, you'll still be close to the answer. Some of them, though, rounding errors will throw your answer off. That first problem, for example, you get thrown off by a rounding error. So keep your digits in your calculator, even if you're not writing them all down for your own personal edification. All right, so number 3 had... You've got $100 paid at the end of each month for 10 years, 50 at the end of each for the next 15, and then 10 forever after. So each of these are at the end of the month. So the first 120 months. Is that what we got? You've got 100 being paid, and then the next 180 months, you've got, bless you, 50 being paid. Oops. And then finally, after that, you've got 10 that's being paid forever. So, for me, I think there's 2 different ways to think about it. I've got one way written on the answer key, which I'll do first. The second way I saw on someone else's paper, which is a perfectly acceptable way to do it. But the way I thought about it was to take this annuity and find the present value. Do the same thing with this annuity and the same, oops, missed the last 50 there. And do the same thing with this perpetuity, right? Now, the other 2, the first one I could just do back with the formula. It'll be 100, A angle 120, and then the interest rate, remember we have to convert, it says it's 3% convertible monthly, so I need to convert it to that monthly rate, which in this case, all I need to do is divide it by 12 and get 0.25%. If I want to use the present value of annuity formula for the next piece, remember, if I use annuity immediate, all that does is take it back to that one period before the first payment, right? Okay, so then I will have to take the whole thing back all the way. So in this case, you would have 50, A angle 180, and 0.0025. That takes it to time 120. I've got to move it back with a v to the 120th to get it all the way back to 0. And then likewise for the perpetuity, Again, when we do the present value of the perpetuity, it just takes it back one step past that before that first payment. I've got to take it then and move it all the way back to time 0 as well. Present value of that perpetuity will be A angle infinity, but I've got to move it back 300 months. So you would need those 3 distinct pieces. Lots of people had the 3 distinct pieces but didn't move those second 2 present values back to time 0. That was an important part of the problem. However, another way to think about this, let me do this in a different color here, so I'm going to draw in a picture. You can think of this perpetuity of 10 starting at time 1. Certainly there's a $10 payment in here, right? And there's a $10 payment in here. And certainly these are $10 payments. So I can think of this as a perpetuity of 10 all the time, right? Now, I've already taken 10 out of this, so if I do 40 starting at time 1, now I've got these 50s here, right? Right? And then notice I've accounted for 50 in the first part, so I can also do 50 here. So I can think of this as 3 different things. I can think of it as a $10 perpetuity, a $40 annuity for 300 months, and a $50 annuity for 120 months, and do it that way. So you can also write this as 10A angle infinity. I'm not going to bother putting the interest rate because they're all the same. And then plus 40 A angle 300, and then plus 50 A angle 120. So I can think about splitting the payments up into 3 pieces. And then you don't have to worry about it. If you do it this way, you don't have any of the V to the N's adjusting, but you will get the same answer. See how those are broken up that way? We're going to see ones in the next chapter where we'll have to break things up into 2 different pieces, so I thought it was nice to go through one of this particular example on the test because we'll see more things like this later. Yeah, Grace. Can I see if there's those on the table before I get to 8?
Yeah.
Okay. Let's see. Let's see, 5. I guess I'll have answers posted on here too. Oh, 7 I wanted to talk about just briefly. Lots of people set things up correctly, but then decided to use guess and check, which is it's a perfectly acceptable way to do it on the exam, by the way. If you can guess and check answers and get the answer, that's perfectly acceptable on the exam. But I do want to mention that one of the techniques that does pop up, and they will, at least in the past when questions have been written, they'll force you to use, is being able to set up a quadratic equation and solve it. Okay? So in this particular one, you should have had an equation that looked like 1.5 times whatever the payment is, times A angle 10I is whatever the payment is times A angle 20I. The problem said a 10-year annuity immediate as whatever present value, the present value of the 20-year at the same interest is 1.5 times as big as the present value of the 10-year. So the x's go away. Obviously, you can divide them out. And then it wants you to use the formula here. Right? So we get the formulas for A angle 10, A angle 20. Multiply both sides by I. Those also go away. You get 1.5 minus 1.5 v to the 10th equals 1 minus v to the 20th. I want to multiply everything by 2 so I get rid of the decimals. and rearrange, this becomes 2v to the 20th minus 3v to the 10th plus 1 equals 0. I get a quadratic equation, right? It's quadratic in v to the 10th. Again, you could, if you got to this point and set it up and did guess and check, you've got the answer sitting there. If you didn't think of it on the exam, that's a perfectly acceptable way to do it. There's no wrong way, that's not a wrong way to do it. However, sometimes on the exam, instead of giving you actual numbers for the exponents, they'll give you an n and a 2n. And then you can't do guess and check nearly as easily. Okay? So that's one of the reasons why I wanted to mention it. This factors as 2v to the 10th minus 1 and v to the 10th minus 1, which gives you v to the 10th is a half, v to the 10th is 1, but this one doesn't make any sense because if v to the 10th is 1, I is 0. 1 over 1 plus I equaling 1 makes the I 0. And then from there you can get what the I is. Again, the main reason why I wanted to mention this is because of the quadratic part that comes up. Okay? Yes, sir. This factored. Yeah, I factored it here. You can do quadratic formula. In fact, quadratic formula also works, but it factors like this. This one actually, but actually knowing the quadratic formula is important too, because some of the problems they give on the exam, you have to use the quadratic formula to be able to do. That certainly is something that you need to know what you do, and if you didn't see how it factored, quadratic formula is not that long to take to do it. Eight. All right. 500 into an account at the beginning of each month for 15 years. Since it's the beginning of the month, it's going to be an annuity due, right? Here's the issue. The payments are going in at the beginning of the month, and they give you an annual effective interest rate, right? So to be able to do the annuity part, the $500 into an account at the beginning of each month for 15 years, I have to change my, actually I was going to use this as a J. I'm going to change that J into a monthly rate, right? This monthly rate compounded for 12 months needs to be equal to that yearly rate. That's what that says. I think you get, I have it in my notes as a 12. Thank you. Okay. So we need to make what our book calls that equation of value again. And then I'm going to make my scales different because of the different ways they're coming in. Okay. Oops. All right. So we've got $500 going in at the beginning of each month for 15 years. So the last $500 payment goes in at time 179, and it'll sit there until time 180. Then we've got the perpetuity paying X at the end of each year forever. So again, we need to find a place to set them equal. Where I set them equal was time 15, or time 180 months. You can move these values forward to time 180, and these x's backward to time 15. That was how I set up my equation of value. You could move them all back to the present, but you would still have to do that two-step process like we did in problem number 3, right? You have to move this back to time 15 and then move it back 15 years. You can do it that way. There's nothing wrong with doing it that way. So if I move these forward, that would be 500 S double dot 180 with that interest rate of 0.00327. This gives us a cumulated value at time 180 months, which is 15 years. And then I want to set that equal to present value of the perpetuity. It's a yearly perpetuity. That's great. Perpetuity. Perpetuity. That's great. Reminds me of Dr. Roth in class when I was a student. If you've had linear algebra, you might have talked about the Graham-Schmidt process. He mispronounced Schmidt in class. It was really funny. The perpetuity is yearly, so I'll use the yearly effective rate for that one to find the present value instead of equal. And you should get 4909. If you didn't convert your yearly interest rate to a monthly interest rate, you would have got a huge number for your annuity. Like really, really big. So this is another one of those problems is we have different periods. We need to make sure we have the different rates. And what else did I want to mention? There was something else I wanted to mention, and I can't remember what it was. Oh, probably using the calculator to find I? Yeah. That's probably what I wanted to mention. So let's just do that real quick. Wait, see the calculator okay? Now can you see the calculator okay? Apparently that's as big as it gets. I would probably just, if I change the display settings. Okay, let's see. Okay, so I want to compute the interest rate using the calculator. So they tell us that the present value is 2,700. So I put 2,700 in for the present value. And they tell us the payments are 300. I want to make sure my payments have opposite sign. So I'll put 300 negative in for the payment. It says we have 10 quarterly payments, so I'll put 10 in for N. And then we'll compute the the interest rate, the I/Y. So you should get 1.963. $10. It was 10 quarterly payments. But this was the quarterly rate, right? This is quarterly rate. If I want to change this to discount for monthly, I would need to go 1 plus I. The I that I would just compute it to the fourth is 1 minus D12 over 12 to the negative 12. And solve for D. But it's much easier to get your I, pardon me, if you use the calculator to compute it for you. As in, it's going to be really, really hard to try to figure out what I is without using the calculator. There'd be a lot of guessing and checking in that case. Are there other questions?
Yeah, can we go through it over two?
Sure. So for 2, remember that for your force of interest, you take your present value and you multiply it by e to the integral, well, not necessarily present value. It's your whatever your value is, I'll say current value at time t1. You would do your e to the integral of t1 to t2 of delta of t dt, and that gives you your accumulated value at time 2.
So you don't multiply the integral by the time?
I don't multiply by the time, no. The time is in here. That's what the dt is. The time's been sliced up into pieces and multiplied by each of the deltas and then added up. So you don't have to worry about the multiplying by time. So you would have 100 as your current value at time 1. And you want to integrate from 1 to x of your 1 over 2t plus 5 dt. And that's supposed to be equal to 140.
Are you multiplying 100 by 8? Or are you setting it?
No, I want to multiply it. Sorry, thanks. And then do your integral. One of the things I saw, people miss the 1/2 out in front. It's easy to do. Put in x, put in 1, combine your log using the subtraction and bring the 1/2 power up. Divide the 100 over, you should get something that looks like 2x plus 5 over 7. Take the square root of that is equal to 1.4. And so that'll get you to x is 4.36. So the square root comes from the fact that you're going to have to move the 1/2 up in your log to be able to do e and log canceling each other. And I have to, the 2x plus 5 over 7 comes from combining the difference of the logs.
Could you do it where you set where you like do e to the 1/2 and then times e to the whatever? Would that give you the same answer?
It won't be times because I'm not adding there. They have to be a plus in the exponent to break it up as a time.
Oh, so you
Yeah, I can't do it that way either. I can take the 1/2 and take it all the way outside, which would still give me the square root. Either that way would be okay. I could do that. I could take care of the 1/2 as doing e to the log of that all to the 1/2. I can do it that way. But I still would have to combine my logs together with the subtraction before I try to do the e to that log. Other questions at all? So how'd the video watching go?
I watched it.
Yeah? Was it riveting?
Yes. Go back to your old stuff.
It was quiet again?
Yeah. You need to put the microphone this way out.
He doesn't talk very loud. He's not me.
Go back to that old stuff where you just ran your last dark rule and you're drawing invisible.
It's so weird.
Where were you guys at filming that?
We were in his unit. There's the basement of the library in this back room, and then in a room inside the back room.
Right on.
Is it recording?
Yeah.
It's just a piece of glass.
You write backwards on it?
You know, you write forward on it, the camera inverts it.
That's weird.
And I agree, it is really weird. I don't disagree.
This
Kinda
is
funny.
weird.
But yeah, it was weird. Did you have any questions over what the video was talking about? Or the formulas?
Pretty, like, similar. Like, you get one, you should have the others, but they're all the same.
Yeah, okay. So we had, what was the idea behind what he was talking about? It was basically you've got payments that are coming in, supposedly, well, the classic scenario would be something like, you're going to get $15,000 a year, but we're going to break it up in monthly payments instead of yearly payments, right? So they quote you a certain amount of payment per a time period, but it gets divided up evenly throughout the time period. Right? I'm going to talk about it because I suppose it's entirely possible that a problem could pop up on the exam where that specific formula pops up. However, the formula looks the same as the other formulas, doesn't it? It's just you have the nominal interest rate in the denominator instead of the effective interest rate in the denominator. But just to talk about where the formula comes from, honestly, I don't see a lot of point in the formula. Because what do you do? Pardon me. How did they even generate the formula? Let's think about it. This is my opinion, by the way. I don't see a lot of point in the formula. Somebody else may have a completely different opinion than I do. Okay? But I don't see the point. All right. So say we've got say I've got n time periods overall, right? And we're going to break those up into m smaller pieces, whatever those happen to be. Okay? So this would be, say, 1 over m, 2 over m, and so on, right? This will be m plus 1 over m, 2m plus 1 over m, and so on down the line, right? And at each of these time periods, you're getting a payment of 1 over m all the way through at the end of each period. I'm not going to draw the rest of the 1 over m's. Getting redundant at this point. So again, the idea is that you've got a payment of 1 that's supposed to be spread out over each period. It's going to be paid over that time interval of whatever period it is, but you're going to break it into m smaller pieces. So like I mentioned before, it's $15,000 per year, but you're going to break it up into 12 months, for example. Does that make sense? Okay, so that's where the 1 over m part is coming from. Well, if you think about how it gets set up, the whole point of this is that you've got this payment of 1 per time period, and the interest rate that you're given is per the time period. Okay? So if I is your, I'll just write it as whole period interest rate, then what will the present value be? Well, just like we did before, I've got to take each of these little payments and I've got to move them back to 0, correct? So you would take your 1 over m, and now I've got to move it back, but I don't move it back a whole period, I only have to move it back 1 over m of a period, right? So I can just write that as v to the 1 over m, right? And then you would do the same thing for the next payment, but I need to move it back 2 over m periods. And I can do that for the next period, but I need to move it back 3 over m periods. Right? This is the same concept we did when we came up with the annuity formula, isn't it? It's precisely the same thing, isn't it? Right? And so on down the line. Your very last 1 over m payment will be at time. I'm going to write it as nm over m. It's a time n, but each of them are over an m period. Now, what does this v refer to? Well, since I said it's v to the 1 over m, this is really referring to the I, correct? That v is in terms of I. So this is where your I is just, V is just 1 over 1 plus I. Right? Okay, well, I'll go ahead and finish off this formula in a minute, but let's think about this V over 1 plus, 1 over 1 plus, equals 1 over 1 plus I piece. If we were going to do this like we did with previous information, we would have said we had mismatched periods, right? We've got a payment coming in at a different time period than the interest rate is. Right? They quoted the interest rate for some one time period. We're given payments for a different time period. What did we do in that case? We just did it on the test. We just converted the interest rate, right? That's all we did, isn't it? We just converted the interest rate. We would have done 1 plus j, where the j is the mthly period, the mthly interest rate, to the m is equal to 1 plus I, right? Do you agree with that? It's exactly what we would have done, right? This j is now the interest rate per small period, I'll say, for lack of a better word. But that's exactly what we would have done and solved for j, correct? Well, if I rearrange this formula, look at what this v, if I do a v, and I want to write v sub j just for emphasis sake, the v would have been v sub I to the 1 over m. Right? The v in terms of j is the same as the v in terms of I to the 1 over m power. Because I would do move the 1 over m over and then reciprocate both sides, right? That's all this is doing. Right? It's doing the exact same thing. So this is why I don't think this particular formula is exceptionally useful. Because if you're given mismatched periods, you're going to change the interest rate to match the period. That's one of the first things that you learn, right? It was one of the first concepts we talked about was having different interest rates at different periods. We talked about how to equate them, right? So my natural instinct, if I see something where I have mismatched periods and interest rates, is to match them. And then just go about the problem. So that's why I don't think this formula is exceptionally useful. Like I said, I think I could envision a scenario in which they make you have to use the formula, but again, the formula is not that much different, right? It's just changing the effective to the nominal interest rate. Yes?
How would it force us to use this versus?
If some of the problems they'll ask you are in terms of the formulas rather than actual numbers. So that's how they typically force. Like the one homework problem I gave you where you had to differentiate the formulas in terms of different variables, it's that kind of problem that could pop up. All right, so much like what we did for the annuities back in chapter, whatever that was, 6, I would factor off the 1 over m. I would factor off a v to the 1 over m, right? So going down here, I'm just getting where the formula comes from. You would take out a 1 over m, v to the 1 over m, and I'm left with that geometric series. Right? Where your common ratio, if you will be the v to the 1 over m. So using our finite geometric series formula, you would have that. Yes? Okay. Yes?
If you factor out a v over to the 1 over m, would you still get 1 over m, v to the 1 over m?
Yes. Because if I had 2 over m, I would have that's a 1 over m plus a 1 over m, so I'm only factoring one of them out. Right? If I have that, right? Yeah, so I would still have those sitting there that way. So let's see if we can manipulate this a little bit. See if we can give it some little bit of manipulation here. This part is just v to the n, right? This part on the top. Right, so I'm not going to play with that at all. I'm going to write this like it's 1 over v to the 1 over m and then distribute it through here. Okay, so this would give me a 1 over m still out in front, 1 minus v to the n, and then you'll have 1 over v to the 1 over m minus 1. Right? I treated the v to the 1 over m as 1 over v to the 1 over m, and then distributed it. Right. I didn't want to touch the top, I wanted to play with the bottom. So I wanted to get this into the bottom. To get it into the bottom, I have to take its reciprocal and then distribute it. That's why it looks this way. But what is 1 over v? That's just 1 plus I, right? So this would be 1 minus v to the n over, I'm going to write m times 1 plus I to the 1 over m minus 1. All right, now this last formula you might recognize, but let's think about how we would recognize it if we didn't. This is just a conversion again. If I've got m periods to make up 1 period for the I, this is our formula, correct? How would I solve for IM? I would take the mth root, raise it to the 1 over m power, that's this piece, right? Then subtract the 1, that's this piece, and then multiply by the m to solve for the IM, right? Okay. So that bottom here is just not A angle. What am I doing? This is a 1. There we go. I started thinking about what the notation was. Okay? All right. The important thing to notice about this, at least according to what you read in textbooks and review manuals, the important thing to remember about this is that even though the payments are technically coming in at 1 over m, when we have this final formula here, it's the total payment for the period. The total payment for the whole period, not the sliced up payments within the period. Right? Notice the 1 over m out in front went away. That's what I'm saying. So this formula at the end here, this number that's multiplied out in front is the total of the payments per big period, not the sliced up payment per small period.
Yes, Sam. So like if the yearly payment was 12, that would be 12?
That would be 12, yep. The notation they use for this, because of course they have to have a notation for it. And then we would still have the I here to denote the period, the whole period interest rate. So they use that superscripted M in parentheses like the nominal we had before. However, that I that's down there to the right of the bracket is the I for the whole period, not the IM. Not that that necessarily matters, because you have to, well, it does matter because here's another annoying thing about this formula, which is why I don't like the formula at all. Okay? This V is not calculated off this I, technically, right? That V is 1 over 1 plus I, not 1 over 1 plus IM. So you've got two different I's floating in the same formula. Okay? So watch out for that too. This is why I said that when I do these problems, I just switch everything to the same period and not have to worry about the formula. Okay? Again, I could imagine that they would expect you to know the formula and have to do something with the formula on the exam FM. But if they've got numbers, I would not bother trying to do the formula. I would just do it like the problems like we've done every other problem.
It's going to be a redundant question, but that's the total yearly payment.
Which is the total yearly
The
payment?
1 minus b to the n over 5.
This is assuming that your total period payment is 1. Making a payment.
Multiply whatever your total period payment was.
In front of that, yep. So if it's a period payment of X, so just put X in front. Not X over that, but X. Yeah, it's a total period payment over 1 month, not a payment per period. Not payment per small period, not broken up payment.
Wait.
So say you were supposed to get $12,000 per year, your per small period payment would be 1,000. But if you're using that formula, you would still use 12,000 in front. So whatever payment goes in front here is the whole period. So if you like yearly, then it would be the whole year's payment. I don't like this formula. I'll be quite honest with you, I don't like it. I like it better than I like numerical analysis, but I don't like this. I don't like this particular formula.
That's a different.
It's a much more visceral dislike. All right, so that's the formula. Again, if you actually have numbers to work with, I think it's just easier to make the periods match and go with the numbers, with the periods matching, than trying to make this new formula up and make it work. That's my opinion. Okay? That's how I attack the problems, and I passed the exam. So, I mean, worked for me. But like I said, again, I can envision, because they will ask you questions about formula manipulation. So I can envision it would be one problem on the exam approach. There's no way it would be more than one. But I can envision where they would ask you to do some manipulation with this particular symbol. They do ask those questions from time to time. But again, if it's numbers, I wouldn't do much more but then remember what the symbol means, and then if you had to, push came to shove, you could start playing around with the formula. But that's me. That's what I would do. So anyway, that is what is it? There's a big long name that they had for this. It's annuity, immediate, payable month, MFLE. Yes. Yeah, MFLE. Annuity, immediate, payable, MFLE. If you do an annuity due where the payments come at the beginning of the small period rather than the end of the small period, you can probably guess how the formula changes. Instead of an IM, it's a DM. Yeah, exactly the same. And you can probably imagine how the notation changes. What would you put above the A? You got it. Yep. So, what's that? We're doing so good, I know. So next time on, for Monday, watch the last 2 videos. I hope the first 4.
Oh. I just not read that.
I said the first 4 though.
I think I just saw one chapter
Yeah.
and I just stopped there and
Well, there are only 2 more, I think, right?
I watched it. There was
Yeah.
6.
There are 6. There's 2 more. It's for the continuous annuities. And we'll talk about where the formulas come from. Those formulas are actually, to me, make more sense. But we'll talk about where those formulas come from next time as well with these problems. Have a good one.
You know, I really thought that I was done for the day. Until I remembered
You gotta see me
that we
again.
had a problem. Now, why am I so tired?
I don't know. Why are you so tired? I always get exhausted at the end of the week.